Welcome to the SQL use case series. The question we want to solve in this video is how to write a single-pass SQL query to find the second largest value in a column. To simplify, we can assume we are looking at a table with a single column. That column has a numeric data type, and that all the values are distinct. In other words, there are no duplicate values. If we have the table shown here, then the expected output for this query will be 4. There are multiple ways to do this, and we'll go through 4 of them. We'll explain the logic by going through the actual code and talk about the pros and cons of each approach. The first approach is using a subquery. The logic behind this approach is that you want to first remove the maximum value from the table, and then you find the maximum value of the resulting dataset, which will then be the second largest value you are looking for. Here is what the query looks like. The subquery finds the largest number, and then that number is removed from the dataset. Then we find the remaining largest number. Note that in this query, we use less than as the operator. Given what we want to achieve is to remove the maximum value, we can also use not equal to or not in. They will all achieve the same result. The pro of this query is that it can be used across all databases. On the other hand, this query cannot be generalized to find the nth largest value. For example, to find the third largest value using this approach, you will need to use 2 subqueries, first removing the largest value, and the second removing the second largest value. The second approach is using the combination of limit and offset. The logic behind this approach is that you order the values in descending order, and you use limit 1 to show one value, and then you specify offset 1 so that you skip the first value shown in the result set, which will be the second largest number. Here is what the query looks like. The order by clause sorts the values in descending order. Limit 1 returns only one value, and offset 1 skips the first value. The pros of this query are that first, it is a very simple query, so it is easy to write, understand, and maintain. In addition, it can be extended to find the nth largest value. To do that, you simply adjust the value after offset. For example, to find the third largest value, you will specify offset 2. The cons of this query is that not all databases support both limit and offset. So, if you are asked this question in an interview and the interviewer specified that the answer needs to be applicable to all modern databases, the interviewer will likely ask you to come up with a different method. The third approach is using a window function. The idea is to use the window function to give each value a rank in descending order, and then you pick the second ranked value. Here is the query. Note that in this example, we use row number. Because at the beginning we specified that all values are distinct, we can also use rank or dense rank, and all 3 will give the exact same result. If handling ties is important, you can then decide whether to use rank or dense rank depending on how you want to treat ties. At the end of the query, we specify that we are looking for the second highest ranked value. The pros of this approach is that it can be extended to find the nth largest value. For example, to retrieve the third largest value, we simply change the last where clause to col1 rank equals to 3. The cons of this query is that not all databases support window functions. Also, compared to the previous 2 approaches, this code is relatively complex. The fourth approach is using a self-join. Here is the code. The idea is that you join the table to itself, and you list out all value pairs subject to the constraint that the value from the first table must be less than the value from the second table. The result of this is that the largest number will not show up in the result set. The second largest number will appear once, the third largest number will appear twice, the fourth largest number will appear 3 times, and the fifth largest number will appear 4 times. Now we can identify the second largest number by zooming in on the one number that appears once in the first column, and this will be the answer we are looking for. The pros of this is that first, it can be used in all databases. In addition, it can be extended to find the nth largest value. To do that, simply change the value in the having clause. The cons of this approach is that the code is quite complex. Also, a self-join may cause performance issues if the dataset is large. SQL is quite flexible, and often there are multiple ways to solve a certain problem. In the case of finding the second largest number, we have shown 4 methods: subquery, limit with offset, window function, and self-join. Thanks for watching. If you find this helpful, give it a thumbs up and subscribe to the channel. See you next time.